Okay, hi everyone. So in this example, we actually have a projectile that's actually coming in here from the left. When it reaches this point here, okay, what happens is that projectile suddenly explodes and it splits into two parts. One part moving in the direction of VA and another part moving in the direction of VB. So what happens in this question? We are actually required to find out what is the speed of the fragment that is moving in the direction of VA, and also the speed of the fragment that's moving in the direction of VB. And the other part that we need to find is the distance dB here. Okay, so for this question, right, in order to start off attempting it, what you need to do is consider the conservation of momentum. So what happens is at the beginning you actually have the bullet, which is a full piece, a whole. So what happens is the mass total is ma plus mb. So the before the projectile has actually broken up into fragments, and the momentum of it is actually that total mass times the speed, and the full momentum of it is in the x direction. Okay, so once it gets to that point in the middle, you can see that it then breaks up. So you need to consider momentum of the fragments, and do remember that momentum is a vector component. So in this case, right, let us first analyze the fragment of mass A. Okay, so what I'm going to do is mass A. Okay, so what happens is it has a velocity that is in the negative x direction. So I'm going to write it as negative VA cos 45. Okay, and it also has a y component, positive y component. So this is actually plus VA. Sorry, I missed to write out the vector, unit vector. So you need to write out the unit vector. So as I mentioned, it's in the x direction, so this one I actually will label it as x. So remember that what we are doing with this unit vectors is actually compartmentalizing the information. So for the vertical, we actually have VA sine 45 degrees y. So as you can see, right, I actually have put for the x direction negative because based on the coordinate system, if we assume that y is positive this way and x is positive to the right, for the x direction, what happens is we are actually having a negative vector based on this coordinate system. Okay, and why y is positive? Because it's moving upwards. So the same goes with the fragment of MB. We do the same. So MB, okay, so I have a positive x direction, and this is going to be VB cos 30 degrees in the x direction. Okay, so plus negative, so I'll just immediately write negative here, minus VB sine 30 degrees in the y direction. Okay, and as I told you guys, right, if vectors is in a way of compartmentalizing the components, so what you should do, right, is rearrange the components a bit. So what happens is you get MA plus MB, so this still remains as is, so 600x. I can say for the y component there's actually no y component, but it's actually 0 if you think about it. Okay, and then now I bring the x unit vector components together, so that would make it negative MA VA cos 45 degrees plus MB VB cos 30 degrees. Okay, and all this information are in the x unit vector direction. And now for the y unit vector direction, so this will be plus MA VA sine 45 degrees. Oops, sorry. Minus MB VB sine 30 degrees, and all this are in the y unit vector direction. So from here, right, what happens is you then compare the components, so within x unit vector and x unit vector, what you compare is the information there. So what I'm trying to say is that MA plus MB 600 will be equals to this negative MA VA cos 45 degrees plus MB VB cos 30 degrees. Okay, let me write it down. MA plus MB times 600 equals to negative MA VA cos 45 degrees plus MB VB cos 30 degrees. And the same goes for the y. You actually have 0 equals to MA VA sine 45 degrees minus MB VB sine 30 degrees. Okay, I'm not going to do the solving of these simultaneous equations, but from my calculation from my Excel sheet, I actually got VA equals to 3090.96 meters per second, while VB takes on the value of 2622.8 meters per second. So you have found the information of the magnitude of the speed of the fragments. Okay, so VA and VB. So for the next part of the question, right, so we're just looking at the fragment of mass B. So what you can do with this, you use your projectile motion equations and consider where the fragments start to separate as the origin. Okay, so it has a launch velocity for the fragment B for example. So then you list down your initial information. So setting origin at the top there means that based on my initial information, initial okay, I would have x initial equals to 0, y initial equals to 0. Okay, so VIY, so this is going to be, so it's pointing downwards, negative VB sine 30 degrees, okay, while VIX is going to be VB cos 30 degrees. Okay, at the final situation, so based on my coordinate system again, my origin, so y final is actually negative 60 meters, and x final is the information I need to find, which is going to be that dB distance. The other information that I know is that in the y direction there is gravity, so there's constant acceleration of negative 9.81 meters per second per second. Okay, so based on this information, I can actually look at the motion of the projectile in x. So in x, so I will skip the formula of x final equals to v initial t plus x initial. So that actually gives me dB, which is x final, equals to vx, that's going to be constant throughout the journey. So VB cos 30 degrees times the time. Okay, and then you have x initial, but in this case, since I've set my origin at that point where the fragment separated, so it's actually plus 0. Okay, so in the y direction, okay, the reason why I'm finding y direction is because I have, in the x direction, I have two unknowns. One is the lateral distance dB, and the other one is time. So for the time of flight, right, I can actually get that information in the y direction. So based on those parameters that I have, right, the ideally suited formula would be the y final minus y initial equals to VIY times time plus half AT squared. So meaning if I will put in the information, y final is negative 60 minus y initial, which is 0, equals to VIY, which is going to be negative VB sine 30, which is half, so divided by 2 times t plus half A, which is going to be negative 9.81 t squared. Okay, and I have solved for the value of t, so we actually get two values of t, one being negative 267 seconds and the other one being positive 0.04575 seconds. Okay, so what happens is the fragment of mass of the B mass moves in positive time. So the value of time that we'll use will be this one here, 0.04575 seconds. So with that time information, we can find dB, which actually, if you multiply the values, should give a value of 103.9 meters. Okay, so that's the answer for dB.